Hi, this is Vinay, and in this ICP6, we are going to perform the clustering using a new data set. So here, basically, we will find the uh, correct number of clusters for the on the basis of the elbow curve that we opted, and then we will be visualizing the cluster results. And another thing is that we will basically explain all the details. And first step is the successful executing the code and making clusters with different values of k. Second step is the using a new and good data set. Third one is the providing the logical explanation of the observations and code quality. So these are the ICP requirements. Now let's move on to the ICP code. Yep. So first step here in this ICP, the first step we are doing is importing all the required libraries. So here the libraries we are importing are the pandas, numpy, sklearn.preprocessing. From that we are importing the standard Scala, and then matplot lib.pyplot, and then the sklearn.cluster we are importing k-means. So pandas are used for the data analysis, and numpy for the operations in arrays, and the standard scalar are used for the standardizing of the data, and matplot lib.pyplot is used for plotting of graphs, and k-means is used for the k-means clustering. So we have executed the first step, and then we need to upload the files. For this we are basically using the files which is from the google.colab library. So here I'm choosing my file. So I'm using my file as final data ICP6. Yep, the data is uploaded. Now we are converting the CSV data by using the read underscore CSV function. Here we can see we have six number of columns, and we have around 240 rows. The data is converted, and in the next step we are taking a count of 30 by using the head function. So we got 30 records into data. Now we are summarizing the data by using the describe function. So here basically the describe function is telling us the count, mean, standard deviation, minimum value, maximum value, 25% of the value, 50% of the value, and 75% of the value. Next, we are scaling of the data. So here the scaling is done by importing the standard scalar from the sklearn preprocessing library. So here the standard scalar function will convert the data into the standard format, and then we are fitting the data. So this is achieved by using the fit underscore transform function. So that will fit the data and will transform the input data to the data points. Then we are displaying the scaled data. Okay. Next, we are doing the statistics of the scal data. So whatever data we have scaled, we are doing the statistical display. So in order to do that, basically we are using the panda function and the data frame, and we are displaying the data. So here I'm considering 5 columns out of 6. Next, we are defining, we are going for the k-mean clustering. So basically here, in this case, we are giving the n number of clusters as 5 and initializing it as a k-mean plus plus. So k-mean, by using k-mean plus plus, we will get the best initial values for the k-mean clustering algorithms. So initially we are giving it as 5 clusters. Here we can see. Then we are fitting the function by using fit function. Next step is to find the inertia. So inertia is nothing but how it is the measure of how good the data is clustered in the k-mean. So here it will give the inertia, and here it's a 6.835. The next step is the here we are fitting the scale data for the multiple clusters. So we have taken 5 clusters, but now let's see for the 25 clusters. So here we are giving the range as 1 to 25, and we are using the init as k-mean itself. We are fitting the scal data, and then we are finding the inertia. So the inertia values is stored in the inertia underscore val, and this is a list that we have initialized. So this function is done. Next step is here we are converting the results into the data frame of clusters and inertia values. So the data frame consists of two labels, clusters, and inertial value and their values. So now let's print them. So once we run this one, we can see that these are the cluster values, these are the inertia values. It's up to 25 since we are given 25 clusters. Now let's plot a graph for the cluster versus inertia value so that we can predict what is the best number of clusters that this model will fit. So once we run this, here I have given 18,9 as a figure size. Then the X label is number of clusters, Y label is inertia value. So here we can see, so this is the elbow curve. We can see it's an elbow, and here we can see that this is the key point where we have the less inertia as well as the less number of clusters. So this is the point where we need to choose and we need to perform the k-mean. So from this graph, we are considering 3 as an n number of clusters. So now let's perform the k-mean for the 3 clusters. Now I'm going to add some more variables of this k-mean, like maximum iteration. I have given it as 20. So max underscore iter, it is nothing but the maximum number of iterations of the k-mean algorithm for a single run. Next, I'm giving it as n underscore init equal to 15. So that means that we are running the k-means algorithm with different centroid seeds. So, and the final result will pick the best value. And we are initializing the random state as none. Now we are fitting the data and we are predicting the data by using the predict function. After that, now we are predicting the data points. We are building a new data frame for this, and we are finding the inertia values as well. So here we can see for this 3 clusters, for 0 it's 12, for 1 it's 11, and 2 it has 7. We are printing the data type and the inertia value. Next, we will be visualizing the cluster. Here we are visualizing the cluster using the scatter function and the scale data. Next, let's since the task is to perform the k-mean clustering for the 5 clusters, so I'm starting it from 3 to 7. So here now let's perform k-means algorithm for 4 clusters. So here we can see for 0 it's 7, 1 it's 10, 2 it's 12, and 3 is 1 data points. So, and this is the visualization of this for 4 number of clusters. Similarly, for the 5 number of clusters, for 1 we have 10 data points, for 0 we have 8, for 4 we have 8, for 2 we have 3, and for 3 we have 1 data points. And this is the visualization. Next, for the k means for 6 clusters, so it's the same. So for 0 we have 1, for 1 we have 8, for 2 we have 9 data points, for 3 we have 8. Next, for 4 we have 3, and for 5 we have 1. And this is the visualization. So the last one for k means for 7 clusters, we can see that these are the number of data points, and this is the visualization. So that's the end. Thank you.